Okay, so number 10 talks about ordering real numbers from least to greatest. So we've had questions. There's a question, I think, on exam 2. Yeah, a question on exam 2 that talked about ordering fractions from least to greatest. And so questions where we order fractions typically, I've told you to use benchmarks or a number line or converting things to a common denominator. But with ordering real numbers, we have to use some different strategies. So remember that the real numbers, oh no, hold on one second. Sorry about this. For some reason, my pencil wasn't paired. Okay. So, can you all hear me still?
Yes.
Yes.
Thanks. Okay, let me make sure there's no one in the waiting room. Sorry, you can tell I'm not used to doing synchronous Zoom. Okay, there was someone else. Okay. Good. Okay, so we're ordering real numbers from least to greatest. So when we do this, we do it a little bit differently than when we do fractions. I think the easiest way to do this, because remember that the real numbers are the numbers that can be written as decimals. The rational numbers are real numbers that can be written as terminating or repeating decimals, and the irrationals are everything else. But the real numbers are all the numbers that can be written as decimals. So I think whenever you're ordering real numbers, writing them out as decimals is probably going to be the easiest way to do it. So I'm going to divide. We have negative and positive here. So we always know that the negative numbers are going to be smaller than the positive numbers. So what I would do is I would have a section of negative numbers. And so that's going to be negative 0.35. And then I'm going to add and go 5 decimal places with all of them. So that's this one. So we also have a negative 0.5. That's that one. And then we have a negative 1/5. So negative 1/5, writing it as a decimal, right? This is something we should all have seen, that 1/5 is 0.2. So this is negative 0.2. That's negative 1/5. We also have negative 1/4, and 1/4 is 0.25. So that's negative 1/4. And then we also have negative 1/3. 1/3 is a bunch of 3s. So these are our negative numbers. And then I'm going to do the same thing, writing out our positive numbers as decimals. So our positive numbers, we have 0.35. And 1/5. And 0.25. Which is 1/4. Wait. Oh, it's just 0.25. It equals 1/4, but we don't need that. And oh, I forgot to cross out the negative 1/3 there. Okay, so these are our negatives and our positives, and then I would order them from here. So we know that we're ordering from least to greatest. I feel as though a lot of you on exam 2 wrote out L to G, and it took me a long time to realize that you all meant least to greatest when you wrote that. Yeah, I hadn't seen that before. I don't know why it didn't click with me for a while. Okay, so we're ordering from least to greatest. So we're ordering the negative numbers first because they're smaller. And remember that negative numbers with bigger absolute value are smaller. So the largest, if we're just looking at the absolute values of the negative numbers, right? So we're not looking at the negative sign. The biggest one is this 0.5. So negative 0.5. We're right at that 5. negative 0.5. The next biggest one here is 0.35. The next biggest one is this 3's repeating, which is negative 1/3. The next one is this 0.25, which is negative 1/4. And then the last one is negative 1/5. And then ordering these positive things over here. So now, right, 0 would go in the middle here. You can put it if you want to. You don't have to. So we're on our number line. We'd cross over to 0 for the positives. And then we're looking at the smallest one here is this 1/5. And then the next one is this 0.25. And the next one is this 0.35. So this is ordering them from least to greatest. So if you're questioning why, I'm actually gonna make this box a little better. If you're questioning why I wrote them with 5 decimal places, it's because with some of the other questions like this, writing out the decimal places just makes it easier. If you have like a 0.3521, a 0.3531, and things like that, you can just kind of compare, right? I have compare it down like this, which is why I wrote them like that, but it was easy to compare these. Yeah, so on ordering questions, if I don't tell you how to do it specifically, then you can do it how you want. So with real numbers, I think the easiest way is to write it out as decimals. You don't have to do that, but you have to show some sort of work. I think a lot of people missed points on the second exam because they didn't show any work for the ordering question, or they, right, on exam 2, I said use these specific methods. If you didn't use those methods, you lost points. If I tell you to solve something using a certain method, you should use that method if you want full credit. So that's number 10. I'm going to let people in the waiting room because I messed up with which device is the host. So give me 1 second, and I'm going to let people in the waiting room. And then does anyone have questions on number 10?
So the 0 that you put in, that's just to show that we're going from negative to positive?
Yeah, so the 0 is not necessary here. I just added it in because if this was a number line, that's where the 0 would be.
Okay.
Okay, so the main takeaway from this is when you're doing an ordering question, show work. That's like the main takeaway you should have is show some sort of work or you're going to lose some points. Okay, so number 11 is about subtracting fractions. So this one is a little bit tricky in its wording. It tells you to specifically, oh, sorry, my pencil got unpaired again. So this one tells you specifically to subtract the proper fractions. So on exam 2, whenever we had the question where we said, explain or describe how to subtract mixed numbers, right? These are mixed numbers. So when we said to subtract the mixed numbers, there were a few people who described the process via converting them to improper fractions. And that's fine for that question. However, for this one, it specifically says to subtract the proper fractions. So this one, I'm telling you, it is a trick question, or it just has very tricky wording because it says to subtract the proper fractions. So that means that we're not going to convert to improper fractions. So we're going to leave them as mixed numbers. We're not going to convert to improper fractions. So to do this, we're going to have to be a little bit clever. So remember that whenever we have mixed numbers, this is really 5 plus 1/3 minus 3 plus 3/4. So we can look at it as kind of subtracting the fraction part and subtracting a whole number part. And whenever we do that, we're going to subtract our fractions first, because we have that 1/3 is less than 3/4. This is something that these fractions are common enough that I would expect you to just know that 1/3 is less than 3/4. So we can rewrite this first 5 plus 1/3 so that we can just directly subtract the fractions and the whole numbers. So this is the same thing as, so if we take 1 away from the 5, we have this as 4. And then if we add 1 to the 1/3, we're going to get 4/3. And then we're subtracting 3 plus 3/4. Okay, so then when we do that, we can distribute that negative sign and reassociate. So this is 4 minus 3 plus 4/3 minus 3/4. And then this is going to be 4 minus 3 is 1, and 4/3 minus 3/4. So I can't do that off the top of my head. So I'm going to write it out here to the side. The common denominator here is 12. So 4 times 4 is 16 over 12, minus 3 times 3 is 9 over 12. And so this is going to give us 7/12. So this is 1 plus 7/12, which is 1 and 7/12. Okay, so just pay attention to the wording. So this one, like I just explained in number 10, it's telling you to do the problem in a specific way. This one isn't as explicitly worded. It says subtracted as proper fractions. This just means don't immediately rewrite this problem like some people have done. So I'm going to write it in red because this is what we don't want to do. Some people think it's easier to rewrite this as improper fractions. So rewriting it as 16/3 minus 15/4. So some people would automatically rewrite it like that. So don't do that. If it tells you to use the proper fractions or the mixed numbers, use the proper fractions or the mixed numbers. Okay, are there any questions on this? Okay, so number 12 is a type of question we've seen a ton of times, is explaining how to do a process. So like I mentioned in the last review session, there were 2 versions of each exam. And so each exam, so on exam 2 and exam 3, we had questions like this that explain how to do this process. And it had different ones on each version. So go back and look to see and make sure you know how, what the other version said. Just because if I asked it on one of the exams, it's more likely that it's something I care about and would ask on the final. So whenever we answer these questions, we should write out steps in a numbered list. That's the easiest way to organize these types of things. So when we're subtracting fractions with different denominators, the first thing is to find a common denominator. So find a common denominator. It does not need to be the least common multiple of the denominators. That is not necessary. So a decent amount of people put that on exam 2. They said that you have to use the LCM or the LCD, meaning least common denominator. That's not true. A lot of times it's easier, at least to some people and to some students you may have, it's easier to just multiply the denominators, because then you don't even have to think about that least common multiple stuff. So it does not need to be the LCM. You can subtract fractions without finding the LCM of the denominators. So don't tell the students that it has to be, because that's not true. So we're going to find the common denominator, and then we're going to subtract the numerators. We're going to keep the denominator. And our last step, always with anything fractions, is or really a lot of things whenever we write out these steps, the last step is always to simplify. So definitely with fractions, that is always the last step, is to simplify. Okay. So 13, I'm just going to kind of go through these 3 in a row and then ask about questions at the end. So the next one is explain how to write a fraction. That should say change. Explain how to change a fraction from an improper fraction to a mixed number. Ooh, sorry. Sometimes it kind of goes crazy. So explain how to change a fraction from an improper fraction to a mixed number. Okay, so this is also one that was on the second exam. So we're going to divide the numerator by the denominator. Okay, so we're going to divide the numerator by the denominator. Remember, every fraction has an implied division problem there. A lot of times we can think of the fraction bar as a division bar. So there's an implied division that we do there. And then the quotient becomes whoops, the whole number part and the remainder over the denominator. Becomes the fraction part. So the reason I put this one on the review is to highlight the vocabulary in here. A lot of times whenever, on past exams, whenever you all have been writing out steps, your language isn't as precise as I would prefer. So a lot of times people say divide the top by the bottom, and then your answer becomes the whole number part. And I just want to point out that for clarity, it's much easier and more correct. I'm not saying the other way is wrong, but it is more correct to use this. We're doing the numerator and the denominator, and then we're looking at the quotient. So these precise words help get your point across more. And it helps avoid any confusion that may pop up of saying top, bottom, things like that could possibly be subjective to a student if you're explaining this to someone. So whenever you're explaining these steps, I mean, I kind of view the whole lens of everything in this class is do it as if you were explaining it to a student who had never heard of it before. And you're going to want to use those precise words that just kind of don't leave as much room for confusion. So if you can, use the vocabulary that we learned, right? Numerator, denominator, quotient. One that I know really, really helps in dividing things is using divisor and dividend. If you don't know what those are, you should. You should at this point. We've talked about division in so many chapters this semester. So I think that's really helpful. There was a question on exam 3, which the exam 3 keys are posted on Blackboard. And I'm in the process of emailing you all your exam 3 graded comments. There's a question on exam 3 version 2 that was about dividing decimals. And it was really hard for me to grade a lot of people's because they just said the thing being divided or the number that you're dividing from rather than saying divisor and dividend. So using those words just helps with clarity. Okay, I know that was a lot, but I'm going to do this last one now about explain how to divide fractions. So the first step here is change. So a lot of times we say change the second fraction. So in this case, changing the second fraction makes sense, right? You can see one's written first, one's written second. But for clarity, we can say change the divisor, right? The thing you're dividing, right? 1/2 divided by 1/3. 1/3 is the divisor. It's also the second fraction. So change the divisor to its reciprocal. And then we're going to change division, division sign, to the multiplication sign. And then we are going to multiply straight across. And then lastly, we're going to simplify. So in this one, you kind of use the multiplication algorithm in this division algorithm. So right here, multiplying straight across, right? That's the multiplication algorithm for fractions. But whenever we learned how to divide fractions, whenever we learned the algorithms, we already knew the algorithms for multiplication. So you don't need to explain the multiplication algorithm in the division algorithm when it uses it. Okay. One last thing I want to say about these explaining how to do things questions is, right, I'm asking you for something that's very specific. So give me that specific thing. Like I just said, on exam 3 version 2, there was a question on how to divide decimals. And some students said, well, you just change it to fractions and then do the division algorithm for fractions. Well, that doesn't tell me that you know the division algorithm for decimals. So even though with decimals and fractions, there's a lot of ways we can convert between them in doing percents and things like that. A lot of the concepts are related. If I ask you how to divide fractions, tell me how to divide fractions using, it's essentially asking you to say the division algorithm for fractions or the division algorithm for decimals or whatever algorithm for whatever numbers. Okay, I think that's all I had to say on explaining how to do things. Does anyone have any questions on any of these three?
On number 14, step 2, is it okay that we just put the X to represent multiplication? Like, I'm not sure if you had said that you, like, because that could be confusing because it could be like a variable X, but is that okay in this situation?
Yeah, I think
Okay.
it's, I mean, if you say it in words, it would say change the division sign to a multiplication sign or change division to multiplication.
Okay.
But I think it's clear that if you have a division sign, the thing right after it's probably the multiplication sign.
Okay.
Okay, any other questions on this? Okay, so we're gonna go to number 15. So number 15 says to convert 4,200 seconds to hours. So this is a unit analysis question. So if you don't remember unit analysis, oh man, I think it's in chapter 5, maybe chapter 4, one of those two. It's in the material for exam 2 for sure. So this is a unit analysis question. We had kind of hard homework on this, where the homework said essentially converting like feet per second to miles per hour, which is a hard question to know how to do. And so the question on the exam 2, there was the same question with a different number on both exams. What was it, 2,400 and 3,200 seconds. So this is a unit analysis question, and there is a correct way to show work on this. So let me go through it. Okay, so whenever we do unit analysis, so the easiest way to write this out is to use a string of fractions that we multiply together. So we're going to start with 4,200 seconds over 1, and we're going to multiply it by how many seconds are in a minute and how many seconds are in an hour. And so we're always going to put our units diagonal from each other. So we know that in 1 minute, there are 60 seconds in 1 minute, and there are, oh, sorry, that should have a 1 minute. So besides that 1 in the first denominator, everything else is going to have a unit on it. So there are 60 seconds in 1 minute and 60 minutes in 1 hour. Okay, so we can see that the seconds are going to cancel and the minutes are going to cancel. So whenever you multiply this out, you're going to get 4,200 over 3,600, and then we're just left with hours. Okay, And so essentially this uses the multiplicative identity property because 1 minute is the same thing as 60 seconds. So putting those things over each other in a fraction is just equivalent to 1. The same thing, 60 minutes is equivalent to an hour. So putting those things over each other in the fraction bar, it's just equal to 1. So then we have this many hours, and we can simplify it. So we know that 4,200 over 3,600. A common mistake was in multiplying 60 and 60 together. 6 times 6 is 36, and then you add 1 0 from each 60. A lot of people on this question put 1,200 instead. So make sure you multiply. This is all multiplying. Okay, so 4,200 over 3,600, well, that's just 42 over 36. We see that both of those are multiples of 6. So this is 7 times 6 over 6 times 6, and the 6's can cancel. So this is just 7 over 6. So this is 7/6 of an hour. Again, a common thing that people did was to convert it to minutes just by dividing by 60. So if it tells you to convert it to hours, give me it in hours. A lot of people put 50 minutes or 45 minutes or whatever, how many minutes it was on the exam. Well, how many hours is that? It's going to be some fraction that may not be, I think one of the answers on exam 2 was like 53.3 repeating minutes. Well, that was however many, whatever fraction it was of an hour. And so it didn't look nice if you converted it to minutes, but if you did the unit analysis the way this looks nice, right? It'll give you an answer that will make sense, but if you do it incorrectly, it may give you an answer that doesn't look nice. So are there any questions on doing unit analysis?
I had a question. So if they say instead of if they say convert dollars per year to a hourly rate, you would have to write like the first in that first farmost left fraction, you would have to say 1 year instead of just the 1, because because in this case, the 4,200 seconds over 1, we don't have to put units for the 1.
Correct.
Okay.
So if you're starting out with a rate that has dollars over years, where YR here means year. So if you have dollars over years and you want to convert that to hours, then you would have 1 year has, I'm not quite sure how the book does it, but 1 year has 12 months. Well, it's probably easier.
Yeah,
just
they
do
did
52 weeks.
They did
Right, 1 year.
52 weeks, yeah.
1 year has 52 weeks, and in 1 week you work 40 hours. So whenever your years will cancel and your weeks will cancel, and you'll have dollars per hour left over. Yeah. So some of the questions in the book and on the homework were a little bit more complicated, where you had rates to rates. Any other questions? Okay, so now we're going into writing numbers. So if you looked at the final exam topics list, there's like a decent section about writing numbers. So you need to know how to write numbers in expanded form, words, and scientific notation. Okay, so writing things in expanded form, we use, this decimals are in base 10. So anytime you see a decimal, you can safely assume that it is in base 10. So that means that this is the tens place is the 4, the ones place is the 3, the 5 is the tenths place, and the 6 is the hundredths place. So when we write that out, this is 4 times 10 to the 1, because that's in the tens place, right? We have 4 tens, gives us 40. And then we have 3 times 10 to the zeros place, which is the ones place, because any number to the 0 is 1. Then we have 5 in the 10th place, which is 10 to the negative 1, and 6 times 10 to the negative 2, so not in the hundredths place. So this is hundredths, right? Because 10 squared is 100, and because of the negative, it's hundredths. So this is how you write a decimal in expanded form. So we have this question on exam 3. If I say expanded form, I'm always going to mean with exponents. So if you see expanded form, that's always going to mean with exponents. So the book considers expanded form with decimals in a slightly different way. They write it with fractions. But the expanded form that we've covered in the lecture videos always was this exponent form. So expanded form is always going to be with these exponents. Write the decimal in words. So this is 43. And 56 hundredths. So the most commonly missed thing here is that this and, the decimal place means and. Some people put point just because it's the decimal point, but the decimal place gets converted to this word and. And then in scientific notation, so recall that the main takeaway for scientific notation is that the biggest place value is the ones place. So that means that you're going to, whenever you have 43.56, that you're going to rewrite it so that your biggest number is in the ones place. So we have this 4, and we want the decimal to go right there so that the 4 is our biggest value and it's in the ones place. Well, so how did we get that? We moved the decimal 1 to the left. So you can see that 43.56 is 4.356. And in order to move from 4.356 to 43.56, you move the decimal 1 to the right. So this is times 10 to the 1. So I think that the way I explained it in the videos is not how I just explained it here, but after talking to students in office hours, I think it makes a lot of sense to place your decimal wherever your decimal needs to go, and then see, well, how do I get the decimal back to where it was? And then that's what you multiply by. So because I went 1 to the right, I multiplied by 10 to the first, which makes a lot of sense. To just place your decimal so that the biggest place value is the ones place, and then count how do you get from the decimal that you just placed to the original decimal in the number. Okay, so overall, you should be able to take any number and write it in expanded form. That includes, expanded form includes base 10 numbers and numbers in different bases. And then writing any decimal in words, writing any number in words in scientific notation, those will only be base 10. Okay, any questions on writing out numbers in different forms?
On 16A, do we have to put the parentheses to separate out the addition, or what do you prefer with that one?
Yeah, so that's a really good question. I don't have a preference because we have the order of operations. So the order of operations tells us that whenever we have this expanded form, we're always going to do the multiplication first. So whether you put parentheses around this or not, you're always going to multiply before you do the addition. So it's the same either way. Any other questions? Okay, so now we have a solve the following equation where in justifying each step, this is a commonly overlooked direction. I'll have you know from exam 3. If I say to justify each step, justify each step. Okay, so there's a lot of different ways to do this. A lot the most common is reverse order of operations, but you don't have to do that. But that's what I'll do just because it's what makes the most sense to us, at least if you've gone through the American education system. We typically learn how to do things like this. So the first step is going to be to subtract 5 from each side. So when we subtract 5 from each side, we get minus 4d equals 4. And then we simplify. It never hurts to just kind of throw in a simplify between each operation that you do, because that's what we do. We don't leave it as 9 minus 5. We actually write it as 4. And then we're going to divide both sides by minus 4. So we're going to divide by minus 4, and then we're going to simplify that because we know that, well, like the 5 and the negative 5 cancel, the negative 4 and the negative 4 will cancel. So we get d equals minus 1. And that's all. Yeah, this is something we've done a lot in algebra. Just make sure you justify each step. And a lot of times you won't often do more than the same operation more than once. I had a few people who were confused and subtracted 5 and then subtracted something again, but you're typically only going to do each operation one time. Okay, are there any questions on this one? Okay. So the next one is something we've seen a lot. It's a question and it just tells you to simplify a bunch of things. So it's been on at least the last 2 exams, so it likely won't go anywhere for the final. I will say, I know that you can't use a calculator on things, and a lot of that is so that you use the algorithms that we've learned throughout the semester. But I will note, if something is really hard, there's likely an easier way to do it, which I'll explain more on one of the examples later on. But if something is really hard or has really big numbers, there's likely a simpler way to do it that you're just not doing. Right? If I typically pick the problems, right? I do all the answer keys without a calculator as well, so I know how difficult the question is. So if something's really, really hard, or you says something that we haven't seen, I know on exam 3 version 2, there were questions that used repeating decimals. And those may have seemed really hard to you if you did one of those questions. But it was something that we had at least learned. We knew how to see how a decimal repeated. And I gave bonus points for people who had that exam, that if they got all the way to the end, just because it did take a little bit longer. But if something is just like outlandishly difficult or uses big numbers, there's likely an easier way to do it. I saw that a lot on exam 2 with some of the fraction questions. Okay. So the first one is dividing decimals. So how do we divide decimals? We make it into a whole number. So we are going to, this was on exam 3 version 2, explaining this algorithm, and I'm going to tell you it right now in words. So what we're going to do is we are going to multiply the dividend and the divisor by powers of 10 until the divisor is a whole number. And I'm going to say it again. We are going to multiply the divisor and the dividend by powers of 10 until the divisor is a whole number. So like I said earlier, whenever we were explaining how to do things in words, if you didn't use divisor or dividend or power of 10, that could have been really hard to parse. If you just said you multiply this number by this until you get something. So we're going to multiply the divisor and the dividend by powers of 10 until the divisor is a whole number. So what does that mean? We're going to move the decimal once here and once here. Say this is the same thing as 425 divided by 5. And then we're going to do that multiplication. right? So whenever we went through in the lecture videos, the division algorithm for decimals, we said that we could write this as a fraction of 42.5 over 0.5, and then you multiply by 10 over 10, and you get 425 over 5. Okay, so we multiply by powers of 10 until the divisor is whole number. And then we're going to put it in our normal long division here. So 5 goes into 4, no times. 5 goes into 40, 8 times. Sorry, it goes into 42 8 times. With 2 left over, carry down the 5. 5 goes into 25, 5 times with 0 left over. And remember, if you have a decimal, the decimal is going to be placed directly above outside the quotient bar, right? Directly above it. So this is just 85 even. There is no converting back. So do not move the decimal in the quotient. This is a really common This is a really common misconception that people wrote on the exam, is that you move the decimal and the quotient back. You don't. You multiplied it by 1. You multiplied it by 10 over 10 if you wrote it as a fraction, so there's no need to move it back. This is just 85. So 42.5 divided by 0.5 is an even whole number 85. So you don't move the decimal back. And a lot of times the questions will relate to each other. Right, when on the exam 3 version 2, when I asked how to divide decimals, there were questions later on that had dividing decimals, and a good amount of people did the correct algorithm with the numbers, but explained the wrong algorithm. I know you all know how to do these operations, but just make sure to think through, do you actually move the decimal back whenever you do this for real or not? Okay, so part B is using fractions. So I'm gonna go ahead, because we have more than one operation here, I'm gonna go ahead and write down the order of operations. So on exam 3, there were, again, a decent amount of people who wrote down the order of operations and then proceeded to not use it. Use it. If you're going to write it down, show me that you know what it means and you just haven't memorized PEMDAS for years without knowing what it actually means. So we're going to multiply and divide before we add and subtract. I think I may have said this in the last review session too, but it's just crazy to me that if you write it down, use it. It's there to help you. So we're going to multiply and divide before we add and subtract. So with these fractions, the first thing I'm going to do is I'm going to multiply this 7 over 6 and this 3 over 14 by multiplying across using the multiplication algorithm. We can see that the 6 is canceled and 7 over 14 is left, and that's 1/2. So this is going to be 1/3 minus 1/2. I skipped a step here with 7 over 14. Well, I'll just go write it. So we're left with 7 over 14. So this is 1/3 minus 1/2. And then we can rewrite that. The common denominator here is 6. So this is 2/6 minus 3/6, which is negative 1/6. I'm sorry, I miswrote almost all of this because it wasn't 6 over 14, it was 3 over 14. Sorry, that should have been a 3 that whole time. Okay, so sorry, that's really a 3. This is 1/3 minus, so our denominator, I'm going to write 6 as 3 times 2 and 14 as 7 times 2 over 7 times 3. So that way our 7s will cancel and our 3s will cancel. And then this is 1/3 minus 1/4. Okay, that's better. And then this is common denominator is 12, so it's 4/12 minus 3/12, which is 1/12. Okay, so in this question, using our order of operations really helped us because we could have looked at this and said, oh my gosh, I have to find a common denominator between 3, 6, and 14, which the common denominator is going to be pretty big. It's going to be the common denominator between 3 and 14, which is 42. So if you just looked at this and tried to find a common denominator, your common denominator would have been 42. And then you would have had really big numbers to deal with. But there's an easier way to do it. If you use your order of operations, you can multiply first, and then the subtraction that you have to do is only 1/3 minus 1/4, and it makes it easier. Okay, so the next one. Well, actually, before I scroll, are there any questions on these first two? Okay, so I'm going to do the next two now. So this next one is doing operations with scientific notation. So this was another question on exam 3, version 1. So this one, all of this is just multiplication, right? There's a little multiplication sign that's right there that we just often don't write down. So this, we can take away the parentheses using the associative property, rearrange things using the commutative property, and put parentheses back using the associative property again. So this is really 4.1 times 1.2 times 10 to the minus 6 times 10 to the 11. So we essentially group the exponents together, right? The powers of 10 together, and then the decimals together. So we group together the decimals and the powers of 10. And then we just multiply each one. So 4.1 times 1.2. Again, this is one that actually a lot of people don't know, the multiplication algorithm for decimals. So whenever we do this, we multiply them like they're whole numbers. So 2 times 1 is 2. 2 times 4 is 8. You put a 0. You get rid of it. 1 times 1 is 1. 1 times 4 is 4. We add it together, and then we get 492. And we just multiply them like they're whole numbers. So I'm going to write it down just because so many people don't know how to do it. So we're going to multiply like whole numbers. And then we're going to place the decimal in the product, right? The product is the result of multiplication. The sum of, so we're going to place the decimal in the product, the sum of the number, okay, this is bad way to say it. May not be easy for me to write. I just don't think I have enough space to write it down. And then to place the decimal in the product, we're going to see how many decimal places are in each of the factors. So there's 1 decimal place in the first factor, and there's 1 decimal place in the second factor, and then 2. Sorry, that should be an end. And then to see how many decimal places should be in the product, we're going to add the number of decimal places in each factor and put that many decimal places in the product. So we're going to have 2 decimal places here. And when you think about this, think about it in a way it makes sense, y'all. I think if you just think through your answer, I understand that time tests are hard and that a lot of people feel time pressure and testing anxiety. But I think that if you just take the time to think through if your answer makes sense, that it can solve a lot of headaches if you forget how to do something. If you get to a question like this and you really don't remember where to place the decimal, well, you can say, okay, 4.1 is really close to 4, and 1.2 is really close to 1. So your answer then should be close to 4 times 1, which is 4. And if you're trying to decide, well, do I place my decimal? Do I place my decimal so that I have 492, 49.2, or 4.92? You know your answer has to be close to 4 because this is supposed to be close to 4 times 1. So that's the only logical place to put your decimal. So just think through, does it make sense? Well, especially when you're doing operations with decimals, just round to whole numbers, see what the answer should be close to and say, okay, does that make sense? It may be less intuitive with division. I recognize that this answer being 85 up here for part A is not intuitive to a lot of people. But especially with multiplication, we should be able to kind of have that intuition. Okay, and now we do the scientific notation. So 10 to the negative 6 times 10 to the 11. So when we multiply, we add the exponents. So this is 10 to the 5th. And then this is in scientific notation. So the answer is in scientific notation. So I didn't count points off for this on the third exam. I gave bonus points for one of the versions if the answer was in scientific notation, because the biggest value here is in the ones place for that 4.92. So that's nice. If you can, you should always convert your answer to scientific notation if you're given numbers in scientific notation to start with. Okay, so the last computation question is 42 over 21 divided by 24 over 14. Using our division algorithm, this is going to be 32 over 21. We're going to change the division to multiplication. We're going to change the divisor to its reciprocal. And there's absolutely no way I expect you to multiply 32 and 14 and 21 and 24 and be able to simplify that easily. I would always factor it. So this, when we multiply straight across in the numerator is 32 over 14. The denominator is 21 over 24. And then 32 is 8 times 4. 14 is 2 times 7. 21 is 3 times 7. 24 is 6 times 4. These are picked so that they work out nicely, y'all. So the 7s cancel. The 4s cancel. So this is going to be 8 times 2 over 3 times 6. So you can cancel it again if you want, where if you can write 6 as 2 times 3 so that those 2's will cancel. And then this is 8 over 3 times 3, which is 8/9. I know I wrote out a lot of steps here. You don't have to write out as many steps as I just did to see that it's 8/9. Yeah, but with fraction questions, multiplying and dividing fractions with big numbers, there's always a way to simplify it rather than just multiplying everything out. If you had a calculator, yeah, multiplying things out is fine. But given the fact that you don't have a calculator, there's likely an easier way to do it. Okay, any questions on these two for doing operations? Okay, and we'll go ahead and go to the last one, which is the percent question. So I didn't ask you any percent increase, decrease questions on the exam, just because those take a little bit more time. But just to recall, 6 is what percent of 30. So remember the percent equation is A equals PB, or A over B equals P over 100. So if you wrote this down, you should have gotten extra credit on the third exam. You can check that once I finally finish sending them this afternoon. So 6 is what percent of 30? So 6 equals what percent? So 6 is the part. 30 is the whole. And we want to say 6 is what percent of 30. So to find that, we can just divide by 30 on both sides. And if we simplify, 30 is just 6 times 5, so that's 1/5. So we know that 1/5 is 20%. So 6 is 20% of 30. So on exam 3, this question, it said to write it as an equation. So most people got points off if you didn't write it as an equation. If it tells you to write it as an equation, write it as an equation. I try to not make the directions on the exam too terribly difficult. Right, the only instruction at the very top is to just show all of your work. that's like the main point of things. But sometimes within the question, it will have directions that you should follow. I'm just going through and boxing all the answers that can be boxed. Yeah. So that's all the review. Are there any questions? I guess on the percent equation for this last one or any of the other questions that we've done. Okay, are there any questions overall? Like I said, this afternoon, I'll finish sending out all of the exam 3 graded submissions, all the comments and all of those things. I guess for those of you that are still here, I know I had said that in the next, well, I'm actually gonna go and stop recording. So I'm gonna stop recording.